Hello and good day, geometry. You already got my spiel from Algebra as far as all the new year, new opportunities, everything like that. Same holds true here. We've got the Google quizzes at the end of each objective for you to take. Math packet number 6 has been posted. Grades for Unit 3 have been posted on Educate. No con due this week, but I will assign it on Thursday, due next Thursday. Okay. Many of you are coming up on placement tests actually in the coming week. Maybe not so much for public schools, but private schools, you're going to start to have that gear up here. For Totino Grace, and I just mentioned that one because I've had a lot of kids go there over the years. You do need to take the placement test coming up this weekend or next weekend, but there's a second one at the end of May or mid-May, something like that, end of April, maybe specifically for geometry. So you'll want to take that one. That's your actual test out of geometry test. So this one coming up is kind of like a baseline test. Just are you ready for high school kind of thing. But there is a second one that you'll need to take later on in the year. As you register for classes, and this goes for public schools also, I know that's coming up too. If you're taking high school algebra as part of your daily curriculum now, and if you are in good standing to test out of geometry to pass this class and have it count for high school credit, you're going to be looking for an Algebra 2 type course. Okay. Now, if you are struggling in algebra and you think it would be best for you to retake it, it's not going to put you behind. Algebra is actually kind of the at grade level course for 9th grade students. So at the Champlin Park, or if you're going to Anoka maybe, or the District 11 folks, it's called Intermediate Algebra. That's the class you'll want to sign up for if you want to take algebra a second time. Okay. If algebra is going well, but geometry isn't so much, then geometry would be the course that you'd want to sign up for. If your intention is a test out of algebra, test out of geometry, go into high school 2 years ahead of your freshman peers, then you're going to be looking for an Algebra 2 type course or an advanced algebra course. Please come see me with questions. Okay, don't sign up for a course just because it sounds fun or you think it's the right one. Talk to me. I'll give you my opinion on it. To test out of geometry, you do need kind of my stamp of approval for that. And so do talk to me before you sign up for an Algebra 2 or an advanced algebra course, just kind of see where you sit. And so that's for mainly public school folks, but for private school, again, there's a placement test coming up. But point is, come and talk to me, okay, if you got questions on where you should sign up. All right, so let's look at CO26, I believe. This unit here, Unit 4, we just got done, Unit 3 talking a lot about triangles, okay, parallel lines, angle relationships, triangles, equilateral, isosceles, triangle proofs, all that sort of stuff. Unit 4 is kind of the extra special features that triangles have. And so we're introduced to things like midsegments or perpendicular bisectors. You've heard of that word before. Or angle bisectors. We have talked about that before. Medians, okay? Unit 4 is kind of all about the extra special features of triangles. We got one PO here, other than the 2 reviews. PO 30, we're going to start out with CO26. What is a midsegment? Okay, a midsegment is a segment, probably could have guessed that, that connects the midpoints of 2 sides of a triangle. There's the written, we always do a picture also, so I will do that under the key point, the midsegment theorem. But a midsegment is a segment that connects the midpoints of 2 sides of a triangle. So what does that look like? Okay, we're going to draw ourselves a triangle here. Try not to make it isosceles because that just doesn't come quite as clear. A midsegment is connect two midpoints of the sides. So let's put a midpoint here, midpoint of AB, we'll call it point C. Let's put a midpoint here or so of we can't call that point C. I already have a point C. I even just wrote it too. We'll call it point D. There we go. We'll call this point E. Okay. And a midsegment, I'll draw it in red here, is going to be the segment that connects D and E. Okay. So DE is the midsegment of that triangle. And there are a couple, actually more than a couple, a few cool things or relationships that we can conclude or that we know exist when we have a midsegment. First of all, we know that D being a midpoint, DB is congruent to DA. We also know that E being a midpoint, AE is congruent to EC. The midsegment theorem also tells us that this midsegment DE is parallel to the third side, the side that is not part of the midpoint connection there, in this case BC. And we know that DE, the midsegment, is going to equal half the length of that third side, BC. So not only is it parallel to it, but it's half the length of it. Whew, that's a lot of stuff, right? Okay, just by knowing that DE is a midsegment of this triangle, we have the congruent side relationships, AD and DB, and then AE and EC. We have the parallelity of DE and BC, which of course opens up all sorts of angle relationships, right? Because we have parallel lines and a transversal here, corresponding angles, those are going to be congruent. These angles will be congruent here, right? Got those angle relationships. And then we also know that DE is half the length of BC. Okay? So these are the key features that you need to get down for the midsegment theorem. What does a midsegment of a triangle tell us? It gives us the relationship of the sides. It gives us the parallel lines, and that DE is half the length of BC. And as it turns out, you don't have to write this part in here, but if we were to label the midpoint of BC, happens to be right about there, I think, okay, and draw these midsegments in as well. You've probably seen those diagrams of triangles kind of going on forever here. You know, if we were to go even further and put the midpoints here and connect with midsegments here, and we continued this. Okay, you've seen those diagrams before, perhaps. Those are all done using midsegments. Okay, kind of neat. But all you need there is the what I originally had, that first DE midsegment drawn in. Okay, so let's use the diagram below and the relationships that we learned about midsegments to answer questions 1 through 4. It says find AC. Well, AC is right here. Of course, we know here we've got all three midsegments drawn in. Okay, DE, DF, and EF are all midsegments. So DE being the midsegment that is parallel to side AC, that's the one we want to focus on, because the one that is parallel to it is also going to be half the length of that third side. So DE is half the length of AC. If DE is 51, AC is going to have to be 102. Okay. Question 2. If AB is 72, so now we have the whole thing here. AB, if that is 72, find EF. Well, EF is right here. That is the midsegment that is parallel to our given side. EF is parallel to AB. So again, we are looking here at that relationship of the lengths. That midsegment EF is going to be half the length of that third side. So if AB is 72, EF is half of that, it's going to be 36. Okay. Number 3, if DF is 45, find EC. Well, DF here, that's our midsegment, that's 45. It's parallel to this side BC, which means that BC is going to be double the length of DF. It's going to be 90. But we don't want BC, do we? We want EC. How do we get the length of that? Knowing the length of BC. I mean, are these two segments here, BE and EC, are they divided in any particular way? Well, yes, they are, right? BE and EC are congruent. So we're looking for what plus itself equals 90. 45 plus 45 equals 90. EC is going to be 45. And then what is the perimeter of triangle ABC? Well, we can use what we previously found to help us with that. We already know that BC is 90. We calculated that. AB was 72. And then AC was 102. Okay. So my quick maths gives me 244. 264. It's been 2 weeks for me too. Let me just verify. Let's see. We have 90 plus 102 plus 72, 264. Exactly what I said the second time. Okay, but there we have it. The perimeter is 264, and we got all this information. I mean, let's go back to our original diagram here. All this information came from knowing that B or the DE, EF, and DF are all midsegments and just one measurement. Of course, then I gave you 2 others here also. Okay, but a lot of information we can conclude based off of very little to start with. Let's look at the diagram down below. It says, in construction, triangles are often used to improve the strength of the structure. That's why if you've ever seen a house being built, the roof, you've probably noticed it looks something like this. Okay, lots of triangles there. Triangle is a very strong shape. A beehive is made of what shape? Hexagons. What is a hexagon? Well, it's basically 6 triangles, right? Very strong shape. In the diagram below, segments UV and VW are midsegments of triangle RST. So triangle RST is a triangle outlined in blue here, the big one there. UV, highlight that there. I'll use red to highlight it actually. Stands out a little bit more. UV is a mid-segment there. VW is a mid-segment there. And they're both mid-segments of RST. So right away, what does that tell us about point V and point U and point W? Right? They are midpoints of their sides. And we are to find UV and RS. So in black, I'll put what we want to find here. We want to find UV, also one of our mid-segments, and RS, this long side here. Well, take a look. What do we know? Where do we want to start? Let's start with UV, just because that came first here. So UV, that mid-segment, it has a relationship with this segment down here in that it is parallel to it and also half of its length. Right? The midsegment is half the length of that third side. So if we know that RT is 90, its associated midsegment UV is going to be half of that. UV is 45. For RS, the side of that triangle, the midsegment that we're going to want to focus on here is VW, that 57. It's the one that's parallel to it. It's the one that's going to have that length relationship. RS is going to be double the length of VW. So VW is 57. RS is 114. Okay. So there you have it. Some properties associated with mid-segments. You've got the midpoints and their properties. You have the parallel side or the parallelity and the half the distance. Everything we wrote down in Theorem 5.1 up above. So go ahead and hop over to the Google Classroom. There you'll find the link for the quiz. Take it. You must get 100%. And if you have any questions, my office hours are from 1:30 to 2. I'll send out just a general Zoom link. Anybody can hop in. We'll just kind of take questions in the order that they are received, or the order that you jump in, or my email inbox is always open. If you've got questions on anything related to this or not, please feel free to send me an email and I'll get back to you as quickly as possible. So my goal is to, since you are at home, post a geometry video daily here. So you'll get one again Tuesday, and then again Wednesday, and again Thursday. If things get kind of piled up, backed up, maybe I'll do 3 this week. We'll kind of see how the week carries on, but that's the plan going forward. So every day, be checking Google Classroom for both algebra and geometry to see what's there. All right, that's how you math. Do not forget to like and subscribe. We'll talk to you later. Have a great day. Bye.